Hi, Evergreen. Let's do Chapter 7, 1 and 2 lessons today. We're going to learn all about quadrilaterals and parallelograms, which are a specific type of quadrilateral, and then also a point of symmetry within a parallelogram. Let's dig in. So a quadrilateral is a shape, which is a polygon with four sides. It has four edges and four corners, which are called vertices, and four interior angles. So we have a square, a rectangle, rhombus, kite, parallelogram, trapezoid, and something called an irregular quadrilateral or an irregular trapezium. There's also something new called convex and concave. Now, concave is a quadrilateral, and all of the interior angles are acute. Oh, wait, no. They're not all acute, but all angles measure less than 180 degrees. The vertices are all directed out, kind of like a kite. And then a convex, one of the angles is a reflexive angle, and one vertex is pointing inwards. And see how this looks like an arrowhead or an arrow, the top of an arrow? And one thing I notice about this is it goes in, okay? And so you see the letter X? It kind of reminds me of the bottom of the letter X. It kind of has an empty bottom, like X. But of course, this could be flipped in any direction, but this is just one way to remember convex. Interior angles of a quadrilateral, whether convex or concave, does not matter. They always add to 360 degrees. And in a quadrilateral, drawing a diagonal line from one corner to the next, you can make points of symmetry or lines of symmetry. So a rectangle has two diagonals, 1, 2, and they bisect each other perfectly in the center, and all line segments are equal. Secondly, a square, same thing. It has two diagonal lines, they bisect each other perpendicularly, and they are all equal in distance. It makes four little triangles, equal right angle triangles inside. And then we have a parallelogram. It has two diagonals. They bisect each other perfectly in the center, creating equal line segments. A rhombus has two diagonals, and the diagonals are perpendicular. Then the trapezoid has two diagonals, but these diagonals are not equal, except in an isosceles trapezoid. And so these don't have any symmetrical markings because none of these line segments are equal. And then a kite has two diagonals. The diagonals are perpendicular to each other. Longer diagonal bisects the shorter one. And so we have equal lengths on left and right. So that's what it means, like this longer line bisects the shorter line, making the shorter line have two equal sections. Okay, let's keep going. So here's a picture of the diagonal, and it's connecting two opposite vertices. The sum of all of the angles inside a quadrilateral is 360. And it's an interesting fact, the exterior angles also add to 360. A rectangle is a quadrilateral, each of whose angles is a right angle. It has four vertices, four sides, right? It has diagonals that bisect each other, creating equal line segments. And so let's answer some questions now that we know about quadrilaterals. Now we look at this shape right here. Is this a parallelogram? No. Is it a rhombus? No. Is it a rectangle? A square? No. Is it a kite? No. Is it convex? No, it's concave. And so this is a trapezoid, and it's not a regular trapezoid, it is an irregular trapezoid. And do you see how they drew a diagonal line between B and D? Yes. And they bisected those angles that bisected angle B, and they bisected angle D, correct? Yes. And so angles 1 and 2 add to angle B, and 3 and 4 add to angle D. And we know that A plus B plus C plus D equals 360 degrees. So we're going to skip to number 2. Angle A plus 1 plus 4 equals 180 degrees. Do you see how it's created a triangle? And so, number 2, the sum of the angles of a triangle is 180. 3, A plus 1 plus 4, A plus 1 plus 4, okay. And 2 plus 3 plus C, oh, so both triangles equals 360 degrees. So why do we know this? Addition, we added 2 triangles together. And then number 4, angle 1 plus 2 equals angle ABC, and angles 3 and 4 equals CDA. Yes, we talked about that earlier. And the reason that those 2 angles add to the 1 is the betweenness of ray theorem. And then number 5, A is equal to ABC plus C plus CDA equals 360. And the reason here is substitution. So if we look up at number 3, do you see how 2 and 3 and C and A, B, C. So A, B, C is equaling their addition. Okay, and so A, 1 and 2 equals ABC. Do you see how we substituted that from number 4? And 3 and 4 is this angle, CDA. And then we just added angle A and C. So now we have 1, 2, 3, 4 angles, all the angles. And so when we add them all together, we get 360 through substitution. Okay, so properties of a parallelogram. So the adjacent angles add to 180 and the diagonals bisect each other. So A and C are congruent angles. B and D are congruent. Also, A and B are a linear pair. They add to 180. B and C are a linear pair. They add to 180. C and D add to 180. And D and A add to 180. If we have 2 diagonals crossing and intersecting within our parallelogram, it creates 4 triangles. And these triangles opposite each other, just like vertical angles are opposite. So with these angles opposite and equal. And also, this is a corresponding parts. And so this length is equal to this length, this side and side. This angle is equal to this angle. And this angle is equal to this angle. And so therefore, it's kind of like our parallel lines and our transversal. We have corresponding angles and also corresponding triangles. Let's answer some questions about this. Okay, so we have 2 parallelograms, A, B, C, D, and over here they have intersected it with 2 diagonals. They have a middle center point E, which is perfectly centered, bisecting AC equally and BD equally. And they want us to notice what we just looked at. AD is congruent to BC, and angle 1 is equal to angle 2, angle 3 is equal to angle 4, and we also know that this angle, unnamed, is also equal. Okay, so let's answer some questions. Because ABCD is a parallelogram, BC equals AD, and why? Because the opposite sides of a parallelogram are equal. And now, also, BC is parallel to AD. BC is parallel. So not only are they opposite sides and equal, but they're parallel. And how do we know that? Well, the opposite sides of a parallelogram are parallel. This is kind of obvious, isn't it? 1 equals 2, yes, and 3 equals 4. But why? Well, parallel lines form equal, oops, there's a typo, alternate interior angles, like we were talking about earlier. Here's our parallel lines, or here's our parallel lines. It doesn't matter which ones you look at. And you have your transversal. And so therefore you have corresponding interior angles. 13, triangle BEC is congruent to DEA. Why? Well, we know there's many reasons: vertical angles, corresponding parts of corresponding triangles, opposite sides equal angles that are equal, but we will go with the side angle side reason, because we know angle side angle. Oops, I said angle side. Angle side angle, because they have told us in our given angle side angle, and that's why we're going to use that proof. 14, BE equals DE. BE equals DE, and EC equals EA. Why? Because corresponding parts of congruent triangles are equal. This diagonal intersects perfectly and bisects this, and so therefore they are equal corresponding parts. Last one, AC and BD bisect each other. Why? A line segment is bisected if it is divided into two equal segments, and it is, because this is a parallelogram. Okay, here's a joke. Why did the parallelogram get off public transit? Because it was the wrong bus. Get it? Wrong bus? Rhombus. Okay, great job, guys. Hope you have a great day. Bye.